Hi, so my name is Satyam, and this is day 3 of my interview prep journey. And in this video, we will solve problem around merge a list. Basically, we need to merge two lists. So let's first understand the problem. So let's say, okay, so what information we have, right? So let's say, basically we need to okay, this function will take two sorted links, uh, linked list in the function should merge two lists into single sorted linked list. The function should return the head of the merged linked list. We need to mutate our original nodes, and you may assume that both input lists are non-empty and contain increasing sorted numbers, right? So let's first understand the problem by example. Okay, so let's say we need to remember that this is sorted and this is sorted in increasing numbers, right? So which means um, 6 7, right? Let's say we have first linked list like this. Maybe we can have like this so that I can visualize much better. And second linked list, we can have like 2 9 6, right? And let's say 11. Okay, so how can we solve this, right? How, what will be the approach that we will take, right? So because this is sorted and in increasing order, right, we can leverage this. Okay, so what we can do is, let's say, because um, if if we have solved before a linked list problem, there's a uh, common way to solve it, because right, we basically we store our current head or current node, and if we want to traverse through linked list, we basically every time we traverse, we reassign with the current node, right, that we have visited. Okay, so this is a very common way, so we will have that. So we, because we have two linked lists, so we need to try, so we need to have two pointers, one for first linked list, right, and second for um, yeah, second for second, right? So how can we uh, solve this? So because this is an sorted array, right? So let's say if I um, start from the um, initial node, or maybe the head, right? So let's say if current one is head currently, right, and we need to return some, we need to return basically a sorted, right, single sorted list, right? So let's say we basically will check if 5 is less than 2. It is not, right, which means um, that uh, that that means we need to basically find a, so no, basically we will check which is smaller, 5 or 2. 2 is smaller, right? So we can have, we can add our new node. Okay, now what we will do, because we have visited this, we will increment our current to here, right? Then we will check if in 5 or 6 which is smaller. 5 is smaller, right? So we will add here. So now because we have visited, we will increment our 8. Okay, yeah, so current will be 8. Okay, And now we will check in between 6 and 8 which is smaller, right? So 6 is smaller, so we will add here because we have added and visited. So we will increment to the next node, which is 11. So current 2 will be there, right? And current is 8 only. Now we will check between 8 and 11 which is smaller. 8 is smaller, so we will add 8 here. Okay. Now because we don't have any other nodes, right? That means we can just get our remaining nodes from current one and add here, right? So basically this is our and now if you can uh, see, this is our sorted linked list, right? It start from the smaller to higher value, right? So this is the approach that we will do. Okay, so let's do this. So what I will do is basically create the dummy node. Why why we will create dummy node? Because we are not sure that the first head uh, should we pick of head 1 or should we pick head 2, because any head can be smaller, right? So that's why we are not sure, so that's why we won't pick the head 1 or head 2, right? So we need to have some dummy node. So let's say if dummy node, it should be same instance. So right, new node. For now I can have null, and then I will track tail dummy node. For now I'll have pointer for head 1, right? Same for head 2, right? Now what we will do is check if uh, current 1 or current 2 is null. We want to basically stop our while loop. So let's add this logic is not equal to null, and which means we need to continue, right? So what we will do basically check for, let's check if current 1 dot value is less than um, current 2 value, right? Which means we need to add current 1 to the dummy node, right? So what I will do is, let's say I will add um, next node of tail to be current 1. Okay, so let's say, okay, now I need to, because we have added current 1 on our tail, we need to reassign or update our current 1 to the next node, right? Because we have visited and the added. So let's do this, right? Else I need to update for the same current 2. Now I need to update same for tail also, like we did for current 1 and current 2. So tail, go to tail dot next, right? Now because we have discussed in the approach that we need to account for remaining nodes, right? For, let's say, for example, if current, so let's solve this. If current 1 has some let's say node, which means we can write like this: if current one is not equal to null, right? I will add the tail dot next to current one. Okay, same for current two. Yeah, now we will return basically dummy node I can write. So I, if I return dummy node, it will be like this. Let's say uh, for this example, this will be like null, then 5, then there will be sorted single nodes, right? But basically we need to return the next, because so that we can view, so that null won't be included, right? So I will return dummy node dot next. Okay, this looks fine. I think a current too well. Let's test it. Okay, dummy node is not here. Okay, maybe there are some, yeah, it should be less than, right? So yeah. Okay, so we have solved this problem. Thank you for watching this video. Bye.